Great to see you here again. My name is Luc de Koster, founder of the Koster Academy, and welcome to my Math Survival Guide. In this episode, I will look at factoring equations and we look at some other quadratic polynomials on which we are using the trial and error method. But before we start, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at factoring again, different equations, different examples, and we are still using the trial and error method. Let's consider 6x to the square plus 5x plus 1. This is a classical quadratic equation, and we want to factorize this using this method. So in this case, we can say that p times q is equal to 6, ps plus qr is 5, and rs is equal to 1. Now, we look at p times q is 6, it's not equal to 1, so we cannot say that p and q are equal and equal to 1, but we have r times s is equal to 1. And basically, this gives us the same thing like we had before. Now we have r equal to s is equal to 1, and of course it will also lead to a simplification of those equations, because now we can replace r and s by 1, and we find that p plus q is equal to 5, and p times q is equal to 6. Now we can follow the possibilities here. For p plus q equal to 5, we have 1 and 4 or 2 and 3, and for p times q equal to 6, we have 1 and 6 and 2 and 3, and we see that the combination 2 and 3 is compliant with both equations, so we can say that p and q are equal to 2 and 3. When we look at the check of the solution, we have to verify that the solution is correct, so we have to expand it again. So we have 2x plus 1 times 3x plus 1, and we find the combination 2x times 3x is 6x to the square, then we have 1 times 3x, then we have 2x plus times 1, and we have 1 times 1, and when we complete this calculation and we add 3x plus 2x, we find that we have 6x to the square plus 5x plus 1 is basically what we wanted to prove. So the factorized form of 6x to the square plus 5x plus 1 is equal to 2x plus 1 times 3x plus 1. Always we put a question mark until we have proven the equality. It's very important that we remind ourselves that we still have to verify the solution. Now let's make it a little bit more complex. Let's add some more complexity. We have 10x to the square plus 19x plus 6, and we don't have those parameters which are equal to 1, so pq is in this case 10 and r times s is 6. So we have to look at some other possibilities. So we say p times q is 10, ps plus qr is 19, and rs is equal to 6. So basically, for p times q is 10, we have 4 possibilities, 1 and 10, 2 and 5, 5 and 2, and 10 and 1. For r times s, we have 1 and 6, 2 times 3, 3 times 2, and 6 times 1. We have to look at all the combinations because the expression is not symmetrical anymore. ps plus qr, when p and q are equal to 1, there was no preference for s or r. We could change them, but in this case, it's not true anymore. So here we have to look at the possibilities that we have to evaluate, and we can start with p and q or with r and s. We can choose whatever we want. It is clear that after some time you will start to look at the possibilities that you can find. So you will be able to find the solutions a lot faster, even without very complicated calculations. So the next step is to look at those equations. Like I said, p times q is 10, ps plus qr is 19, and rs is equal to 6. We start with those different solutions that we find before, and I will start with p and q, and my case 1 is p equal to 1 and q equal to 10. Based on this, I can rewrite the equations. So S plus 10Q is 19. So PS plus QR is 19 is now S plus 10 times Q is 19. And R times S is equal to 6. Now we look at the possibilities of R times S equal to 6. We have 1 and 6, 2 and 3. We have the others 1 in the next step. And now we calculate S plus 10R. So for the first one, we have 1 plus 60. S is 6 and R is 1, so we have 16. This does not comply with the solution. The next one is 3 plus 20 is 23. It also doesn't comply. So now we have to look at the other possibilities. So we start again. Now we have R and S, R, 3, 2, 6 and 1. And we do the calculation again. So we have 2 plus 30 is 32, also not correct. And 1 plus 60 is 61, which is also not correct. So basically case 1 when P is equal to 1 and Q is equal to 10 does not give us a possible solution. And now we have to go to the second case. So basically we continue until we find a solution. So the first one combination we can scrap. And we go to case 2. And case 2, in this case, I say P is equal to 2 and Q is equal to 5. We do the same thing. Our equations are transformed. So we have 2S plus 5R equal to 19. And R times S is equal to 6. So we do the same calculation. R and S, we have 1, 6, 2 and 3. Those are still the same values because we only have P and Q that are changing. And the equation 2S plus 5R also changes. So now we have 12 plus 5 is 17, which does not comply with the solution. And now we have 6 plus 10 is equal to 16. This is also not a solution. But we still have two other cases, two other values for R and S to verify. Let's have a look at that. So here we have R and S 3 and 2 and 6 and 1. So basically now we have 4 plus 15 is 19. And yes, we are lucky, so we can stop here because we found a solution and we now know that P is 2 and Q is 5 and R is 3 and S is 2. So basically we found a combination that gives us a solution. The only thing we have to do now is to verify if this is correct. So these are the numbers that we have. And now we have to verify the correctness of them. So what we have now is in fact the control part of the evaluation. So we have 10x to the square plus 19x plus 6. Is this really equal to 2x plus 3 times 5x plus 2? Is that the factorized form? So we have to expand this again. So we have to do the calculations like we did before using the distributive property. So I have 2x times 5x is 10x to the square. Then we have 3 times 5x is 15x. Plus 2x times 2 is 4x. Plus 3 times 2 is 6. And now we continue with the equation and we can say that we find 10x to the square plus 19x plus 6, which is basically equal to the equation where we started from. So basically that's it for the video for this example, a more complex example. And basically the complexity is in the fact that we have more possibilities that we have to evaluate. But the steps are basically the same. So that's it for this video. Don't forget to click on the subscribe button. Don't forget to click on the bell button so every time we have a new video, YouTube will inform you about it. I thank you very much and I'm looking forward to seeing you in our next video. Thank you and bye-bye.